All right, guys, hopefully we don't get cut off this time. 10.5 lesson, we're going to talk more about some arcs and chords. We have another theorem to talk about, always in math and geometry. In a circle or two congruent circles, two minor arcs are going to be congruent if and only if their corresponding chords are congruent. Now remember what a chord is. It's like an extension chord. Starts and stops. So here, segment AB is a chord. Segment AC is a chord. Segment CD is a chord. Segment BD is a chord. They all have endpoints somewhere on the circle. So the first thing we're going to do here, for example 1A, is we're going to name two congruent chords. Well, if you notice here, we only have one pair of congruent chords. These two are not. So we have segment AB and segment CD. Now we want to name two congruent arcs. Well, according to the theorem, if the converse, the other way around, I mean, you could say two arcs are congruent or the corresponding chords or vice versa. Here, since we see these two chords are congruent, that means that their arcs are also going to be congruent. So here we have arc AB and arc CD. All right. We are going to find the measurement of the arcs in part B. So right now we don't know what they are, but we know that they're the same, and we've done something like this before in notes. What we do when we don't know a number, we're going to use x. And we know that they're both congruent, so they're both going to be x. So here what we'll have is we're going to have 2x. Okay, we have 2 x's plus our 20 over here plus our 220. All equal to 360 degrees, all the way around 360 degrees. Go ahead and solve that on your own, okay? Pause it and solve it on your own and see if you get it correct. Just solving for x. We're going to wind up with 2x plus 240. Go ahead and subtract that 240. We're going to have 2x is equal to 120. When we divide by that 2, we're going to find out that x is going to equal 60 degrees. So each one of those is going to be 60 degrees. Okay. The next one looks a little weird. We don't really have a quadrilateral inscribed in the circle like we did before, but everything's going to follow the exact same. So let's take a look at what we have. We are told that the length of PS, so from here to here, the whole length of PS right here, is 12. We see here that TR, so from T to R, this whole section is 15. We want to find QR, this guy right here. So what I want you guys to see is we have PS over here. Its entire corresponding arc is actually going to be 70. So arc PS is going to be equal to that 50 plus the 20, giving you 70 degrees. Okay, so this together, 70 degrees. And if we notice, arc QR, I also call it QR since the name of the segment, QR, is also 70 degrees. So what that means is, since arc PS is congruent to arc QR, segment PS will be congruent to segment PQ. So since the two arcs are congruent, their corresponding chords will be congruent. So we could say, therefore, QR is also going to be 12. Since PS is 12, QR is going to be 12. Okay? Just looking at different ways of seeing things. On number 3, we've got another inscribed quadrilateral. So we will take a look here and say, all right, we're given 3 of the arcs. We need to figure out what the length of HI is right here. This is what we're looking for. Okay? So let's figure out what its arc is to make sure, because in this problem, it's probably going to be congruent to one of these 3. All right? So we're just going to take that 360 all the way around, subtract the 113, subtract the 91, subtract the 78, and we're going to get 78. So we find out that HI right here, arc HI, is 78 degrees. And since now we see that arc GH is congruent to arc HI right here, since these two arcs are congruent, that's going to mean that the two corresponding chords will also be congruent. So we'll say, therefore, GH, the length right here, 9, is equal to HI. So HI will be 9. All right? Remember, pause it. You need more time. Next, we're going to look at the perpendicular chord bisector theorem. Okay? This lets us know that if a diameter or even a radius is perpendicular to a chord, then it's going to bisect the chord and its arc. Okay? So here we're told that segment AD, right here, this radius, is going to be perpendicular to segment BC. So that means we're going to have, do it in a darker color, we're going to have a 90-degree angle right here. All right? Because they're perpendicular. So because, according to this theorem, what's going to end up happening is it's going to bisect this chord, and it's also going to bisect the arc, okay, the corresponding arc. So CE and EB will be congruent. Chord CD and chord DB will be congruent to each other. All right? So we're looking through here, and we're told that the radius, so I'll do this in a color, make it a little better. Well, first we have AE right here, just from here to here is 12. And then we have AD, which, I'm sorry, not AD, sorry, our radius is 13. So we're going to keep that in mind. All right? We don't have, I mean, we do have the radius right here, but I don't want to mark it. We'll see what we're going to, we'll go ahead and mark it. Why not? Right here is 13. So, first thing they want us to find is the length of ED. So here we want to find from E to D. Well, our radius is 13. We're going to take away AE, because that's 12. So we come up with just a single 1. There's your length. Next we want AC. So AC is going to be actually not drawn in there, but if you draw AC in, you're going to notice it's another radius. So we're going to write here so we know why we wrote it as 13. AC is a radius, so it will be 13. Want to know AB? Well, AB is over here on this side. Oh, look, another radius. So AB is a radius. So again, we're going to have 13. Now we want to find EB. EB is right here. To find EB, we're going to have to do a little bit of work. Okay, I'm going to come over here. I'm going to draw just this right triangle, triangle AEB, the best I can, so it looks like that. Okay, here's our 90-degree angle. Here's A, B, and E. Well, we know that AE is going to be 12, as it labels right here. We know that AB is our radius, so that will be 13. So we use our Pythagorean Theorem, or if we know our triples, we know that this is a 5, 12, 13 triple. Okay, but we'll just go ahead and use our Pythagorean Theorem. We're looking for a leg. So we have A squared plus our other leg, 12 squared, is equal to 13 squared. So go ahead and solve this one on your own. Once we do our Pythagorean Theorem work, A squared is going to equal 25. Square root it. That missing part is going to be 5. So here we're going to have to use Pythagorean Theorem. Now let's take a look at EC. EC is going to be right here. Well, what we know is that EC is equal to EB. See those congruent marks? Remember, we had perpendicular, so it bisects that chord. So EC is going to be equal to EB, so it will also be 5. The last one they want us to find is going to be the length of BC. That's this entire chord. Well, all that is EC right here plus EB, the other side. We just double it. And so that's going to equal our BC, what we want. So it's going to end up being 10, because we have 5 here, and we have 5 here, total of 10. Okay? Got to draw on a lot of stuff there. Okay? We don't have as much to draw on this one. Okay? This will be a little bit more simple. We're looking at, they're telling us that we have, they're telling us already that they're perpendicular. So already we know that this chord is cut in half, it's bisected. We also know that its corresponding arc is bisected as well. Okay, so we're going to go ahead and draw that in. We're told that the measurement at an angle, arc CFB, so we go C to F to B, this entire major arc is 220 degrees. Okay? So the first thing they're asking us for is to find the measure of arc CB. Arc CB is going to be down here. Okay? Well, all we have to do is take that whole 360 degrees, subtract that 220 from our major arc, and we're going to wind up with 140 degrees. Simple and easy, just a subtraction. Next, we want the measure of angle CAB. So we go from we're going to go from C to A to B. So what we're looking at is this guy right here. Okay? Well, if we remember, we found that the arc BC, this goes back to the last unit, the arc's measurement was 140 degrees. Well, at angle CAB, we have our central angle. And so since we have a central angle, our central angle will be congruent to that corresponding arc. So that will also be 140 degrees. Now we want the measurement of angle BAD. So what we need to realize here is we have this segment right here, AE, is, go back to first semester at the very end, is a special segment. We have a perpendicular bisector. Perpendicular bisector is also going to be an angle bisector. So if this angle is 140 degrees, that means half the angle, angle BAD, we just take that 140, divide it by 2, and we wind up with 70 degrees. The last one, we're wanting arc CD. Well, arc CD is going to be congruent to its central angle. And we already decided that since this is bisected, each one of these is 70 degrees. Or we can look down here and say, okay, we have arc CB, 140, it's been bisected. So we're just dividing that 140 by 2 again, and we're getting that 70 degrees. All right, next, taking a look at another triangle in there, but we got that right angle, right? Okay, so let's look at what they've given us and what we need to do. We know here, let's just go ahead and SQ. So this entire side right here, this whole chord is going to be 12. They really like that number 12. And AT right here, just the small portion right here, is going to be 8. We want to find TR, that little tiny part right there. So we have part of the radius, because AR is going to be our radius. We have part, AT, but we've got to figure out what the radius is so that we can figure out what this last remaining part is. So what I want you to look at is here, AS is a radius. So if we use this triangle AST, and use Pythagorean Theorem, we can figure out what our radius is. Remember that we have this 90-degree angle, so they're perpendicular, which means this has been bisected. If the whole thing is 12, that means ST is going to be 6. So if we draw that triangle to the side to use our Pythagorean Theorem, here we have AST. This is 6. This is 8 if you have your triples memorized. This is a multiple of 2 of one of your triples. Or we're looking for C. So C squared equals 6 squared plus 8 squared. Go through that process. 36 plus 64. C squared is going to equal 100. When we square root those, we're going to find out that our radius is going to be 10. So AS right here is a radius, and it's going to equal 10. We found out the Pythagorean Theorem. AR, this whole section right here, is a radius. So that's going to equal AS. So these two will be congruent. We'll put in here, they're both radii. We got a little bit of writing to do just to remind us why we came up with these answers. So what's going to end up happening is TR, what we're looking for right here, is going to be equal to the whole radius, AR, minus just the little part we have, AT. So TR will be, we've got our whole radius, AR, of 10, minus that little part, TR is going to equal 2. All right. Last page, ladies and gentlemen. We are almost there. We're going to use this diagram, and we got a 30, 60, 90 going on here, don't we? All right. Well, we know that these will be congruent. We may or may not need to know this, but we've got that radius and a chord perpendicular, so the chord and the corresponding arcs are going to be bisected. So here, I'm going to go ahead and draw this guy to the side just to kind of make it a little bigger. It's kind of a small triangle here. It's definitely not drawn to scale. There's our 30, here's our 90. We've got A, C, and then over here D. We know that our hypotenuse is going to be 6. So we need to remember our labels for 30, 60, 90. Across from our 30 degree is going to be A. Across from our 60 degree is going to be A square root of 3. And across from our 90 degree is going to be 2A. So what we have here is 2A equals 6. So we take 2A equals 6. Let's take half of it. A is going to equal, sorry, not 6, 3. So then over here we know that this side, CD, is going to be 3. And then down here all we need to do is substitute in for A. A is 3, so we have 3 square root of 3. I'm just going to go ahead and solve it ahead of time. Pretty sure I'm going to have to use all that stuff since I have it. Let's take a look. AD. Okay, so we went from A to D right here. Well, AD right here was 3 square root of 3. Now let's take a look at CD. CD is right here, only part of that radius. Well, CD right here, we found out was 3. And now comes the fun part. We want the measure of arc AB. So we want arc all the way from A all the way to B. Okay? Well, arc A to, well, there's no point here, right? But here our central angle is 60. So this section right here would be 60. Add your other congruent arc of 60. We have a total of 120 degrees. Our equidistant chord theorem. Equidistant meaning equal distances, okay? In a circle or congruent circles, two chords are congruent if and only if they are equidistant from the center, okay? So we're going to find x and y here. What I want you to see is that equidistant from the center, that's meaning the chord up here, the top chord and the bottom chord, are the exact same distance from that center. How do I know? Because of these congruent markings. So what that tells me is that the two chords are also going to be congruent. Guys, we also have something else in here. We've got this part radius perpendicular to those chords. So it's going to bisect these chords right here. Okay? Now the thing here is, since the chords are equidistant from the center, these two chords are the same. That means all four sections will be the same. So all we have to do here is say x is, well, x is 8. It's the same. It's congruent. X is 8. Y is going to be the entire thing. So it's just going to be the exact same. 8 plus the 8, giving us 16. Really nice, sweet, and simple on that guy. Okay? The last picture may seem overwhelming, but let's go through step by step and see what we know, okay? One thing we do see here is that we have two chords here, and they are perpendicular, so we know that these are going to be bisected, okay? And we'll go ahead and go through and look at what we have. FL, So from F to L is 3. So hey, that tells me this is 3 also. GO is 5. So I'm going to go from G to O. This guy will be 5. And then OP, O to P is 4. Now if you use Pythagorean Theorem over here, you're going to find out this is your 3, 4, 5 triple. That means this LO will also be 4. So since these two chords, FG and HJ, are the exact same distance, 4 units from that center, the entire chords will also be the same. All right? So we want to find HJ, this entire thing over here. And we're going to go, okay, well, we just found out that LO is equal to PO. Therefore, since they're equidistant, FG will be equal to HJ, making HJ whole thing, if it's 3 and 3, just makes it 6. Picture looked overwhelming, but we got stuff, we've got it figured out. So go back, rewind if you need to, and I hope that you understood it all.